All right. So you've seen when we draw these diagrams out that we're getting a little bit more complex. When we step into this first time we do a ramp, just getting used to what those normal forces are, okay? We're going to put this now object on a ramp. This is going to be the 20 degrees it's talking about. The box is going to be here, okay? The interesting thing is that we've always learned that there's a component to the weights, and that's the ones we're going to have to figure out for most of these problems. So if this box has a weight and it's 20 kilograms, okay, so the weight of 20 kilograms, let me put the 20 kilograms over here. The weight that is here is actually going to be the mass times the 9.8, so this is going to become 19.6 newtons. Okay, the weight of that box is 19.6. Now, there's no way this is going to move downwards, so there's two things I'm going to have to know. I've got to learn and figure out what's that part of the weight that wants to bring this box sliding down this way, and what's the part of this weight that is pushing it into the bottom of the board. The reason we perpendicularly into the board, that's the weight part that's perpendicular to this, because that's also going to give us what the normal is. You've seen in these previous examples, the weight and the normal usually are what equal each other. So from our previous, sort of breaking these into the x and the y parts, here was our x, here was our y, we had a relationship where we said, the x part of any vector is equal to that same vector, force, times the cosine of theta. And the y part, let me make sure that looks like an x, the y part of this is that force times the sine of theta. Now that's true when it's down on the ground, okay? But what's interesting is that in the ramp, this is 20 degrees, and it's this angle that's the one we need the angle for, because of the, right in here, I mean. And it's the supplement to that, or complement to that. And that ends up actually flipping which fraction, the cosine of a complement is equal to the sine of that same angle. These two just get switched. And instead of trying to help my students to figure out what that one is and go through all that work to figure this out, I found that in a ramp, these cosine and sines switch. So what we think of this is normally the x-axis, and if you want the component of that on a ramp, you're going to use the sine function on a ramp. You're going to flip those, and that's what the notes say. But if you can remember this is your one way to get the x part or y part, then you can say on a ramp they flip. So in order to get in this problem here where what's the normal force, this one up here is what I'm going for, I need to know what's the perpendicular part of the weight that goes perpendicularly into this board. Okay, and that's called the force perpendicular. If I want to know that, this looks like a y component. Okay, normally it would be f sine theta, but we're going to flip this because we're on a ramp, and it's going to become the force, which is the weight, times the sine. Sorry, there I did it. Let's get that out of there. The weight times what we normally would say sine theta, but we're going to use cosine theta because those switch. So that's cosine of that angle 20. Okay, so weight times the cosine of 20. 19.6 times the cosine of 20 is going to end up becoming 67 newtons. Nope, I'm reading the wrong one. My apologies. Okay, this is the force perpendicular. I'm just reading it wrong off here. Is equal to 18.4. Okay, so 19.6 times the cosine. Let's write this a little more clearly. So this is the force perpendicular, and that's going to be the weight times the cosine of theta. And I calculate that out to be 18.4 newtons. Okay, so this portion of this is the vector that's being portioned here, is 18.4 newtons. That means then, just from these other ones you saw, that these two have to be equal. That's going to be 18.4 newtons in the up direction. So in the opposite direction is this. So the normal is just whatever the force perpendicular is. The force perpendicular is the weight times the cosine of theta. So that's the toughest one. So this answer comes into here being 18.4 newtons. Okay? Notice if we just know that there are these forces that we have to always deal with, that's going to simplify in our minds to remember what's all involved. we're going to have the weight. You're going to have the normal force because that's going to help us get some friction. And then anytime you have weight on a box like this, some of it's going to go down the slope. That's going to call the force parallel. And part of it's going to go straight into the board. That's called the first force perpendicular. So that's something we're going to have. We're going to have a couple more here as we're working our way down. So don't lose hope yet. You're going to get the hang of this. And it is. The first time it's like, wow, this is a lot of work. You're going to get used to those because those are the forces that we want you to get used to drawing and then just figuring them out. We'll point out some things that are easy to help remember.